been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This is the video for geometry section 10.5. We're going to look at angle relationships in circles. And so there are three theorems that we're going to look at here. I didn't write out the theorems. You're welcome to go get those from the book. I just am kind of giving you a brief synopsis of what it says and going to show you what it means when we're looking at a circle. So the first one we're going to look at is angles formed by a chord and a tangent. So just as a reminder, segment AB is a chord and line AC is a tangent because it intersects the circle at only exactly one point. And so what happens here is that you'll notice that the tangent and the chord intersect at point A, and the relationship is that the angle formed by the chord and the tangent is equal to 1/2 the arc that is formed. So the measure of angle BAC is equal to 1/2 arc BA. In the same way, the measure of angle BAF is equal to 1/2 the measure of arc BDA. That is a major arc, and arc BA is a minor arc. Remember, with major arcs, we want to make sure we use 3 points, which is why I have that point D on the circle there. So it is pretty much just like the last theorem in the last video, which was an angle formed by two chords that intersect on the circle is equal to 1/2 the intercepted arc. So it's very similar. It's just that instead of two chords, it's a chord and a tangent. The next relationship is angles inside the circle. So we have two chords here. I have chord AB and I have chord CD, and that forms 4 angles. And the angles inside the circle is going to be this. The measure of angle 1 is going to be equal to 1/2 the sum of arc AC and arc BD. So let me show you what that means. So this angle here, angle 1, is equal to 1/2 the sum of this arc and that arc. So if you notice, it's this half the sum of the arcs formed by the angle, which is angle 1, but also its vertical angle, which is angle 3. So the measure of angle 2 is going to be equal to 1/2 the measure of arc BC plus the measure of arc AD. I'm going to do one more. The measure of angle 3 is equal to 1/2 the sum of arc BD plus arc AC. So you should notice something here, which is this is the same as that, which should not surprise you because angle 1 and angle 3 are vertical angles which are congruent. It's important to know this equation and also be able to work with it given really any information, not necessarily thinking you're always going to get this part. You might know the angle and need to solve for one of the arcs, which is fine because we can do algebra. Our last relationship has 3 examples that go with it, and this is angles that are formed outside the circle. So in this first example, I have a tangent and a secant that intersect outside the circle. And so the measure of angle 1 is going to be equal 1/2 the difference of arc AD minus arc CA. So it's the difference of this arc minus this arc. So it's the difference of the intercepted arcs. You want to make sure you subtract the smaller from the larger and take half of that. The next example is 2 tangents, and they intersect outside the circle at point B. And so the measure of angle 2 is going to be basically the same thing. 1/2 the difference of arc ADC minus arc AC. So notice how I named the major arc using the letter D, because I can't just use AC for both. I have to make sure I know the difference. And our last example is 2 secants intersecting outside the circle at point C. Again, it's going to follow the same rule. The measure of angle 3 is going to be equal to 1/2 the difference of arc AE minus arc BD. So with all of these, it's important, again, that you know the formula, you know the rule, but also that you're able to manipulate that and not think that it only works one way. So you need to understand that in each of these, there are 3 unknowns. There's the measure of the angle and then 2 arcs. And so given 3 unknowns, you need to know 2 of them in order to solve for the third. But sometimes you have to be creative in how you find things out. So I may not tell you what the measure of arc AC is. You may have to find it, because maybe I give you arc DC and I give you arc AD. Well, you can find the third arc by subtracting the sum of AD and CD from 360 from a previous lesson. So again, take all the information you know and try to apply it as best you can. We will be applying these theorems in class. Please make sure you understand them and how I got them.
I've been waiting way too long.